Let's try to understand what is a function. To understand this, I have taken an example where there is a lady which is trying to bargain with this auto wala. Apparently, the meter of this auto is not working. So this auto wala has this condition that he'll note the number of kilometers from his odometer, and the lady has to pay 10 times the number of kilometers plus 20. So 20 rupees is the extra that he's charging for his service. So this lady is little sharp and she tries to quickly find out the relationship between the two variables. So she figures out that there is a variable, let's say Z, which reflects the amount, the fare. So let's call this fare in some currency, let's say rupees. And then this fare depends upon the number of kilometers. So let's assume that this X is the distance in kilometers. So if we try to figure out the relationship between Z and X, or how Z depends upon X, we can write Z is equal to 10X plus 20. So this lady figures out that the variable Z, which is a dependent variable, because this Z depends upon X. So let's call this guy as some dependent variable. And this X, which can be anything, which depends upon how much distance does the lady cover, we can call it as independent variable. So this is how the independent variable X depends upon the dependent variable Z. And in mathematical terms, this is nothing but a function. So we can say that Z is a function of X, which is represented by Z is equal to 10X plus 20. So that's it. That's what function is. A function is representation of how a dependent variable depends upon the independent variables. So a function can be anything. For example, suppose you have the function y is equal to x squared plus 6. So this is fairly a function where y is a dependent variable and x is an independent variable. So y is equal to x squared plus 6 is how y varies with x. So I can write y is a function of x. There can be plenty of such examples where we can relate a function to a real life situation. But if you talk about functions in general, then this is a really nice idea. So mathematically what we have done is try to represent the relationship between variables in the form of a mathematical expression where we can quickly figure out how the relationship changes as one variable takes different values. Now, obviously the functions can be in more than one variable. For example, suppose the auto wala might say that the fare not only depends upon the amount of distance traveled, but also depends upon the time spent. So in this case, the fare will be a function of x, that is distance traveled, as well as time. So as an example, suppose the auto wala tells the lady that the fare Z will depend upon the distance as 10 times the distance traveled in kilometer plus 5 times the time spent in minutes. So this is a function of two variables, that is x as well as t. So there can be different functions which can depend upon one or more variables. I can give you one more such example. For example, the well-known gravitational force. So you know that the gravitational force F is equal to g m1 m2 divided by r squared. Here you can say that this force F is a dependent variable, right? And this dependent variable depends upon three variables: the mass of the two bodies and the distance of separation between them. So we can as well say that force, that is a function, depends upon the variable mass of first body, mass of the second body, and the distance of separation between them. So from here it is clear that as we change m1 or m2 or r, F is going to change. And G is here is the constant of proportionality. Now next we want to discuss about the graphical representation of functions. Now what do we mean by graphical representation of functions? For example, you have function y is equal to 2x. So this is a function where y is a dependent variable which depends upon independent variable x in this manner. So if you want to graphically represent this function y is equal to 2x, assume that x varies along this axis, which we represent as x, and y varies along this axis y. So as you change x, suppose x is 1, what is going to be y? Y is going to be 2 in that case, right? Suppose x is 2, in that case y will be 4, 3, 6 and so on and so forth. So the basic way to plot a relationship is to quickly put the values of the independent variable and then find out what values it gets for the dependent variable. And with these pairs, just mark different points and then join all the points to find the locus of those points. And that what we call as the graphical representation of the function. So in simple words, in this case, y is equal to 2x. So suppose if you put x as 1, you get y as 2. So let's call this point as, suppose this is 1. So 1, 2, 3. Let's take 3 points. So 1, 2, 3, 4, 5, 6 and so on. So for 1, it is going to be 2. So it is going to be this coordinate. For 2, it is going to be 4. So it is going to be this coordinate. Similarly, in this side, for minus 1, y is going to be minus 2. So similarly, approximately here and here. So I'm not taking all the points, I'm just taking the points which are convenient to me. But the relationship is general. So in this case, the function, the graphical representation of the function will be a straight line joining all these points, and whatever points will fall on this line will satisfy the equation y is equal to 2x. And in mathematical words, they will be also called as solutions of this equation, right? So 1 and 2 is such a solution. So I hope you understand what do we mean by representing the functions graphically. Now let's understand few terminologies that are used really often in mathematics. One such terminology is called as domain. So what is a domain? Suppose a function, let's say y is equal to x squared, and this function is defined from real numbers to real numbers. Now what does it mean? What do you mean by saying that okay, this function is defined from real number to real number? So this side on the left hand side, this tells you that what values an independent variable can take. So in this case, the independent variable is x. So this means that the x can take the value of any real number. Okay. In simple words, this x is called as domain, or the domain of this function will be all the real numbers. And what is called as range? Range is all the possible set of values that you get after you put your domain. So in this case, when you put domain as real numbers, you're only going to get positive real numbers as range. Now don't get confused when I say that the function is defined from real numbers to real numbers. Real numbers include negative values, yes, but this thing is called as codomain. Now what does it mean? Is that range is actually the subset of codomain, or it is a small part of the codomain. So understand it like this. This function is defined from real numbers to real numbers. Domain implies that what are the possible set of values that x can take, and that is the real numbers. So real numbers is going to be the domain of this function. Now this function is defined from real numbers to real numbers. It means that all the real numbers is a part of the codomain, right? But when you put the different values of x, you're only going to get the positive real numbers, because it is a square. The function is defined as y is equal to x squared. So when you square any negative real number also, it is going to give you positive real numbers. So in that case, when you actually put the values that belong to your domain set, you're only going to get positive real numbers, and those positive real numbers is the range of this function, right? So 3 definitions: domain, codomain, and range. I hope this video clarifies what a function is, what is its use, and why we mathematically try to generalize things.